Hi everybody, it's Miss Craig again. This is our try it video for lesson 1, the week of April 27th to May 1st, similarity and similar polygons. So this try it was slightly different. It was set up like an assessment. When you get to the end of the assessment, you are able to check to see if your answers are correct. So in this try it video, I'm not doing every single problem that was in the try it, just a few select ones. So this was problem number 1 in that assessment. So if you haven't done that yet, go ahead, work out the problem, pause the video, and then come back and check your answer. So the big thing when we're doing the similarity statements is we have to make sure that we are matching up those congruent angles in the same order. So if we start with A, in the first one, we have to match up what would be that similar triangle or similar angle in the second one. So if we see they're not turned the same directions, you kind of have to imagine that we take this one and we kind of rotate it around so it's facing the same direction. So if we kind of look, A kind of has that point, that acute angle, so E would also have that same acute angle. So if we keep going around, next it has us go to B. So B follows that diagonal side down. So if we follow the diagonal side down, we would get to B. We keep going around. We now go on the straight side to C, which if we keep going around on the other one would take us to O. And then finally, we end up at D, and if we keep going around, that will end us up at L. So the figure ABCD is similar to the figure EVOL. So the next one we're going to do was actually problem number 3 on the try it. So again, if you haven't done it yet, pause the video and then come back. So on this one, I think it's helpful to draw a picture. So it's telling me that I have a rectangle. I am not an artist, which is 3 2/10 centimeters wide and 8 centimeters long. And it's similar to one that's smaller, that's 5 centimeters long, and we do not know the width. So if we use our proportionality, if I'm doing the width of the big one, which is 8, I have to then use the width of the smaller one. So I could say 8 to 5. I'm sorry, the length of both of them. So the length of the big one is 8. The length of the big one is 5. I'm sure if we were in class, you guys would have mentioned that I spoke incorrectly. So now, if I started with the big one in the numerator, I have to keep the bigger one in the numerator. So now the width of the big one is 3 2/10 centimeters. Then I do the width of the smaller one is x. And then I can solve by using my cross multiplication. So 8 times x is 8x. I would take 3 2/10 times 5, which would give us 16. In order to solve for x, we would divide both sides by 8, and we would get x equals 2, and we want to attend to our precision. So my width would be 2 centimeters. So the next one we're going to do was problem number 4 in the assessment. So again, if you haven't done it yet, pause the video, work it out, and then come back. So first we want the similarity statement of the larger triangle to the smaller triangle. Again, remember, order matters. So we have to make sure that we are looking at it in the right order. So if we look, we could tell that the triangles are almost as if we had to take this one and like flip over a hamburger so that they're facing in the same direction. So if we start with C in the first one, we notice that if we would flip it over, that would get us to F. in the second one. And then the triangle follows in order. So now we have B. So here's B. Again, since we kind of think that it's flipped over, that would take us to G. And then lastly, we had A, which is up here on the top, which is going to match with H, which would stay up at the top. So if we're finding the similarity ratios, remember that's when we have to make sure that the sides are matching up. Again, we'd have to go in order. So if we go from C to B, we can see if we go from C to B, that's also F to G. So that would give us 48 to 8, which is 6. And the similarity ratio should, again, be the same for all of them. But if we want to check, if we now go from B to A, we know that that would also then be from G to H. So that would give us 72 to 12, which is also 6. And if I just want to make double sure, if I now come A back to C, that would also be H back to F. So that would give us 84 to 14, which is also 6. So therefore, our similarity ratio would be 6. So on problem number 5, there were several ones where you were finding a missing side on the triad assessment. We're just going to do the first one. So if you haven't done it, pause the video and then come back. So we're going to use our similarity proportionality. Again, order matters. So when we go to set up our proportion of similarity, we know we have A to B. We have to keep in the same order. So that means we would compare J to K. So again, our rectangles are facing in different directions. We have to imagine that they have been rotated. Then if we compare A to D, so if we start with the smaller one in the first one, we have to keep the smaller one in the second one. Again, so A to D, we would have to keep the same order, so that would be J to M. And then we can fill in our values. So A to B was 12, J to K is X, A to D is 6, J to M is 9. So in order to solve, we would use our cross multiplying. So 12 times 9 is 108. 6 times x is 6x. Divide both sides by 6, and we would end up with x is equal to 18. So next, make sure you have done the rest of the practice on the triad assessment. You can check your answers at the end. If you're in my class, there's activity 2 on practicing solving equations. When you're nice and comfortable, you're going to go ahead, hit next, and take the show what you know assessment. And we will talk again soon. Take care.